Alright class, today we're going to learn about the gas laws. It has to do with gases, state of matter. Jokes of the day. I would make another chemistry joke, but all the good ones are gone. Argon's a gas. Noble gas, so to speak. Speaking of noble gases, if a king farts, is it a noble gas? Think about that one. Alright, gas particles. The particles will move rapidly and also collide constantly. They have a total volume of the volume of their container. Particles will occupy a small part of the total volume because we have a lot of empty space between the gas. There's very little mutual attraction or repulsion between the particles, meaning we're not going to count the collisions between the particles. And they also cause changes in direction and velocity. Your standard units for your gas laws. One is pressure. Pressure is the force of the gases divided by the area of the container they're in. You can use 1 atmosphere. That's equal to 101.325 kilopascals, 760 millimeters of mercury. That's how much the pressure of a mercury thermometer will go up at 1 atm. They give you these units in your reference materials. They might ask you to convert from one to another. Make sure you go over your dimensional analysis. Volume, it's usually liters, although you sometimes use milliliters. Temperature, we typically use it in Kelvin. All that is a Celsius plus 273.15. They also give you that equation on reference materials. So just as a general hint, if they give you in the reference materials, you'll probably need them at some point on your STAR tests. Your number of gas particles are expressed in moles, that's letter N. Alright, now we're going to look at different situations that will change our gas properties. If you decrease your volume, that's going to lead to increased pressure. Here I have a cylinder container where there's some gas particles, and let's say I take this chamber and I squeeze it downward. By squeezing it down, obviously the particles are going to bounce more against the walls. There's less space there. Assuming we have the same temperature, assuming we're not increasing the speed of the particles, the pressure will increase. Another way to write this is pressure is related to 1 divided by your volume. Next one, increased temperature leads to increased pressure. That's assuming the volume is the same. So let's say we take our piston and we lock it in. We're going to add heat to it. So here's my extra heat. By adding heat to it, we're going to increase the kinetic energy of the particles. By increasing your temperature, they're going to bounce along the walls more, and by doing that, you have more pressure. The next one, increased temperature leads to increased volume. So, here I have my particles. On the left, I'm going to add my fire to it. By doing that, they're going to be moving faster. Assuming I want the same pressure, if it's going to bounce along the walls of the container more, then we'll have to have more volume. It's going to push the cylinder out more. In this one, volume and temperature are directly related to each other. And that's the only one that's a direct relationship. Next one, increased moles of gas or more particles lead to increased or more pressure. Here I have a set locked in position piston, meaning no volume will change. I'm going to add more particles of gas. Obviously, if I add more particles, there's going to be more collisions against the walls or more pressure. Next, let's go over some applications of the gas laws in everyday life. Engines and pressure of your car engines. Typically, you're going to add gasoline. It's going to mix with the air, moves in a cylinder. Then you have your pistons of your cylinder moving up and down. By making decreased volume, pushing it up, will increase the pressure inside the cylinder. Now when that works, it's going to also increase the moles of gas. That causes, again, the pressure to increase. This reaction is very exothermic. The temperature will increase, and that contributes to more increased pressure. By changing the pressure, the increased pressure pushes the next piston down, and then turning the crankshaft, this moves up and down, that connects to your gears of your car, and that's why your car wheels move. So it all is based on the volume and pressure and number of particles of gas. Breathing. It has your diaphragm. A lot of times people say breathe through your diaphragm. What that means is you're going to contract your diaphragm, the chest will expand, and that causes the lungs to expand. You actually change your pressure by doing that. So we start with 101.3 kilopascals, we're going to decrease to 100.9. And that causes your air to move into the lungs faster than it moves out. Then your diaphragm relaxes, the chest will return to original volume. This increases the pressure of the lungs, causing air to move out faster than it moves in. Having a net change of gas particles will allow you to take in oxygen. Next, your ideal gas law equation. PV, pressure times volume, is equal to the number of moles times R. R is just a constant depending on the pressure units, times your temperature. Now the usual tip-off that you're going to use this is if you have 3 properties and asked to calculate the 4th. Okay. Another one is if you only have 1 gas, you're going to use the ideal gas law. Alright class, so the reason why I showed you all of these different pistons moving, changing volume, pressure, temperature, and moles, you're going to probably see a lot of situations where you have to calculate a new answer. I want you to think about what the answer should be. Should it be bigger or smaller, depending on the situation? Also use your equations. They're on page 1 of your reference materials. You have all your gas law equations, don't need to memorize it, but you do need to know which one to use and calculate. If you have any other questions, leave a comment down below or shoot me a message.